All right, so I'm helping out with this problem here um, because I see that nobody has done it so far. So the exponential rules, right? And we have some negative exponents. So what is the process? There's different ways that you can approach it, but let's see how I'm going to approach it, right? So I don't care about the negative exponents so far, right? I don't want to turn them into positive. So what I'm just going to do now, I'm just going to apply the power rule. The power rule means that if I have the exponent on the outside and all the exponents inside, I'm going to have to multiply them. Okay, so that's all I'm going to do. So I'm going to have the 5 here times the negative 4, the negative 5 times the negative 4, and then the 4 times negative 4, right? And that should give me x to the power of negative 20, right? Y to the power of positive 20, because negative 5 times negative 4 is positive 20. So y to the power of positive 20. And then 4 times negative 4 is negative 16, so it's z to the power of negative 16. Okay? Now, I'm going to take care of whatever is at the bottom. Okay? And here, same thing, I'm going to have the same process. I'm going to have 5 times negative 5. So x to the power of negative 25. And then I have negative 2 to the power of negative 5, that's positive 10, so y to the power of 10. And then what z, we have negative 3 times negative 5, that's positive 15, so I'm going to put z to the power of 15. Okay? So we know that the final product, or the final answer, has to have negative exponents, right? So we're going to use all the technique of all the rules first, and then at the end, when we get the final answer, we take care of the negative exponents if any remains. Okay, so now if I have the same base and I have this quotient rule, right? So I have to use a quotient rule. The quotient rules means that I'm going to subtract negative 25 from negative 20, right? And that's the way it's going to look. It's going to be x to the power of negative 20. And I have to subtract negative 25, so subtract minus negative 25. Okay? I'm going to do the same thing for all of them with the same base. So we have y to the power of 20 minus subtract 10. And then here, z to the power of negative 16 subtract 15. Okay? So that was the quotient rule. So now I have x to the power of negative 20 plus 25. So 20 plus 25, negative 20, I'm sorry. So x to the power of negative 20 plus 25, right? The double negative. And at the end, it's going to be x to the power of 5, right? Negative 20 plus 25 is 5. So x to the power of 5. Then I have y to the power of 20 minus 10. That's y to the power of 10. And then the last one is negative 16 minus 15 is z to the power of negative 31. Okay, so the first two, they have positive exponents. I don't have to do anything with that. But the negative exponent is going to move from the top, or being a numerator, to be a denominator now. Alright, so next, it should look like x to the power of 5, y to the power of 10, over z to the power of 31. Okay? Or you can look at it like this, x to the power of 5, y to the power of 10, times 1 over z to the power of 31, right? If you follow the negative exponents rule, and then you multiply these two, the x to the power of 5 and y to the power of 10 will just be multiplied by 1, not the z to the power of 31, okay? So, and this is what you get. Okay, that's it. All right.